Hello friends, myself Mr. S.M. Ganwat, Assistant Professor, Mechanical Department in Sharad Institute of Technology, College of Engineering, Yadra. Today we are going to discuss robot applications. Now we are going to discuss need to replace human labor by robots. The first need is work environment hazardous for a human being. Second, repetitive tasks. Third, boring and unpleasant tasks. Next, multi-shift operations. Next, infrequent changeovers. Next, performing at a steady pace. Next, operating for long hours without rest. Next, responding in automated operation. And the last one is minimizing variation. Now, industrial robot applications can be divided into material handling applications, processing operations, assembly applications, inspection operations. Now we'll discuss one by one. First, material handling application. It involves the movement of material or part from one location to another. It includes part placement, palletizing, depalletizing, machine loading and unloading. The next application is processing application. It requires the robot to manipulate a special process tool as the end effector. The application include spot welding, arc welding, riveting, spray painting, machining, metal cutting, deburring, and polishing. The next application is assembly. It involves part handling manipulations of special tools and other automatic tasks and operations. And the last one is inspection operation. It requires the robot to position a work part to an inspection device. It involves the robot to manipulate a device or sensor to perform the inspection. Now we will discuss all these applications in detail. The first application is material handling application. This category includes the following: part placement, palletizing and depalletizing, machine loading and unloading, stacking and insertion operations. First we will discuss part placement. The basic operation in this category is relatively simple pick and place operation. This application needs a low technology robot of the cylindrical coordinate type. Only 2, 3 or 4 joints are required for most of the applications. Pneumatically powered robots are often utilized. The next part that we are going to discuss is palletizing and depalletizing. The application require robot to stack part on the top of the other, that is to palletize them, or to unstack part by removing from the top one by one, that is depalletize them. Example: process of taking parts from the assembly line and stacking them on a pallet or vice versa. The next part is machine loading and unloading. Robot transfers part into and or from production machine. There are three possible cases: machine loading, in which the robot loads part into a production machine but parts are unloaded by some other means. For example, a press working operation where the robot feeds sheet blank into press but finished parts drop out of the press by gravity. Machine loading, in which raw material are fed into machine without robot assistance. The robot unloads the part from the machine assisted by vision or no vision. For example, bean picking, die casting and plastic molding. Next, machine loading and unloading, that involves both loading and unloading of the work parts by the robot. The robot loads a raw work part into the process and unloads a finished part. For example, machine operation difficulties. The next part is stacking and insertion operation. In the stacking process, the robot places flat parts on top of each other, where the vertical location of the drop-off position is continuously changing with cycle time. In the insertion process, the robot inserts parts into the compartments of a divided curtain. The robot must have following features to facilitate material handling. The manipulator must be able to lift the parts safely. The robot must have the reach needed. The robot must have cylindrical coordinate type. The robot's controller must have a large enough memory to store all the program points so that the robot can move from one location to another. The robot must have the speed necessary for meeting the transfer cycle of the operation. The next application that we are going to discuss is processing operations. A robot performs a processing procedure on the part. The robot is equipped with some type of process tooling as its end effector, manipulates the tooling relative to working part during the cycle. Industrial robot application in the processing operations include spot welding, continuous arc welding, spray painting, metal cutting and deburring operations, various machining operations like drilling, grinding, laser and water jet cutting and riveting, rotating and spindle operations, adhesive and sealant dispatching. The next application that we are going to discuss is assembly operations. The applications involves both material handling and the manipulation of tool. They typically include components to build the product and to perform material handling operations. They are traditionally labor intensive activities in industry and are highly repetitive and boring. These are classified as batch assembly. As many as 1 million products might be assembled. The assembly operation has long production runs, low volume. In this, a sample run of 10,000 or less product might be made. The assembly robot cell should be a modular cell. One of the well-suited areas for robotics assembly is the insertion of odd electronic components. The next application that we are going to discuss is inspection operation. Some inspection operation requires parts to be manipulated and other applications require that an inspection tool be manipulated. Inspection work requires high precision and patience and human judgment is often needed to determine whether a product is within quality specification or not. Inspection tasks that are performed by industrial robots can usually be divided into following three techniques. By using a filler gauge or a linear displacement transducer known as linear variable differential transformer, the part being measured will come in physical contact with the instrument or by means of air pressure which will cause it to ride above the surface being measured. By utilizing robotic vision, matrix video cameras are used to obtain an image of area of interest which is digitized and compared to a similar image with specified tolerance. By involving the use of optic and light, usually a laser or infrared source is used to illustrate the area of interest. The robot may be in active or passive role. In active role robot is responsible for determining whether part is good or bad. In the passive role, the robot feeds a gauging station with the part, while the gauging station is determining whether the part meets the specification. The robot waits for the process to finish. Now we are going to discuss advantages of robots. Robotics and automation can, in many situations, increase productivity, safety, efficiency, quality, and consistency of products. Second, robot can work in hazardous environment. Third, robots need no environmental comforts. Fourth, robots work continuously without any humanity needs and illness. Next, robots have repeatable precision at all times. Next, robots can be much more accurate than humans. They may have milli or micro-inch accuracy. Next, robots and their sensors can have capabilities beyond of humans. Next, robots can process multi-stimuli or tasks simultaneously. humans can only one. Next, robots replace human workers who can create economic problems. Now we are going to discuss disadvantages of robots. Basically, we are going to categorize disadvantages of robots into three. First is robots lack capability to respond in emergencies. This can cause inappropriate and wrong responses, a lack of decision-making power, a loss of power, damage to robot and other devices, and human injuries. The second category involves robots may have limited capabilities in degrees of freedom, dexterity, sensors, vision system, real-time response. And the last category includes robots are costly due to initial cost of equipment, installation cost, need for peripherals, need for training, and need for programming.